everyone, this is Miss Moriarty, and I'm here to discuss with us topic 6.5, which is once again talking about our fossil fuels known as coal, petroleum, as well as natural gas. Remember, it's important to note that when we harvest fossil fuels and we combust them for energy, this chemical reaction between those fuel and the oxygen gas we know tends to then create carbon dioxide, water, as well as the energy that we're going to use as electricity. Now, methane, natural gas, gasoline, propane, butane, coal, all of those are examples or forms of fossil fuels that contain what's called hydrocarbons, meaning that carbon and hydrogen are going to be bonded together. And when they interact with oxygen gas, they're going to then create CO2, water. And when the bonds break, energy will be released and then harnessed. Now, how is that energy harnessed and actually turned into electricity? Well, typically at, say, a coal power plant or maybe even a natural gas power plant, actually are going to turn that energy into electricity very similarly. The general steps for each is we take that fossil fuel, such as coal, for example. What you're going to do is you're going to combust that fossil fuel. You're going to burn it. Now, you're going to burn that. That's going to produce heat. Now, what happens, you can kind of see that in where you see like the boiler here. In that boiler, we're going to have large amounts of water. We're going to heat that water through the combustion of coal or, say, natural gas, and that water is then going to form steam. That steam is then taken to turn a turbine of some sorts. That turbine is then going to begin to spin as a result of the production of that steam. That mechanical energy or kinetic energy from that turbine is going to then power a generator, and then that generator will produce the electricity used in, say, like your home to turn the lights on or to heat the water in your shower, for example. Now, once again, just some environmental consequences of using things like coal. We know that it can destroy habitats since we have to mine for coal. We know that in the combustion, it produces things like greenhouse gases. Can also produce particulate matter such as soot or ash that can act as an irritant in your respiratory tract. It will produce trace metals such as lead, mercury, or arsenic. When these items are produced, they can be taken to landfills or maybe stored in ash ponds. And in the atmosphere, they can release things like SOx and NOx, sulfur oxides, nitrogen oxides, which are also irritants to your respiratory system, and have the ability to create what's called acid rain or even smog. Specifically looking at the extraction of petroleum or oil. Here, this fossil fuel is going to be obtained through drilling wells underground into rock layers, so kind of like subsurface mining here. Before we can actually turn it into, say, crude oil and the petroleum that we know of, we tend to recover things such as tar sands, which we've said before are combinations of clay, sand, water, and bitumen. Bitumen is the thick, then sticky, semi solid form of that petroleum, not in that liquid form just yet. But to obtain it, this process does need lots of water to be heated to then create steam. That steam is then piped down into the tar sand. It melts the bitumen into a liquid, and then it flows upwards up to a pipe in where it can be transported to wherever it may need to go. Now, remember, in the extraction of petroleum or oil, we're going to then use that crude oil and further potentially separate it into other types of materials through fractional distillation, which we know can create things like plastics, maybe jet fuel, and so on. So, environmental consequences of that habitat destruction will also come with the extraction of oil or petroleum. Water depletion, since water is used in the process of obtaining that petroleum can also create water contamination, since once again, water is going to be used for that process. And the CO2 released by the machinery during its extraction will also contribute to global warming, climate change. How do we obtain natural gas? We mentioned in class before, this is through hydraulic fracturing, or known as fracking. Here is where we obtain natural gas from the sedimentary rock that typically lies actually above petroleum deposits. A vertical well is going to be drilled down into that sediment layer, and then it actually turns horizontally into the rock layer. Now, what happens is these fractures or these cracks is actually where a lot of the gas is going to be stored within the rock, and that's what we're going to try to basically be cracking to then obtain the natural gas. And so fracking fluid, which is a mixture of water, salts, acids, detergents, is going to be pumped into the well at incredibly high pressure to make those fractures, and then it allows the natural gas to flow out. The natural gas is going to be collected up at the surface and shipped for any processing or any use that it may have. And flowback water that was used in the fracking process can flow back out of the well and is usually collected and or stored. Now, because of the process of how we obtain it, it does have the possibility of leaking and contaminating groundwater. We said the fracking fluid contains lots of different substances that have the potential to contaminate your drinking water. Ponds that they then use to store that fracking fluid could overflow, leach into the ground, could be toxic to any nearby plants or animals. Simply just using, obviously, water in general is going to deplete the ground or surface water that might be nearby. And creating those fractures in earth can actually even increase the potential activity for earthquakes in that area, since we are now creating fractures in the rock. All right, everyone, that's it for topic 6.5. Make sure as you watch the video, you took notes. Please mark this as done, and we'll further discuss in class as we continue to work on our superhero villain debate project.